Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to talk about how to evaluate trigonometric functions at the axes, basically angles that terminate at an axis. And so prior to this, you have to know pretty much all the material that's been covered in this video series for trigonometry so far. That includes angles, radian measure, right triangle trig, and unit circle trigonometry. And this kind of rounds out how to evaluate trig functions at angles. So this is kind of the end all be all of it. It's kind of a wrap up video, to be honest with you. In these cases, when you have an angle that lands or terminates at an axis, like this one right here, if I quickly sketch this out, in radians, the angle here ends at or terminates at 90 degrees, which is pi over 2. So that ends on the y-axis. The best way to evaluate trig functions on an axis is to remember your unit circle. If I were to draw a unit circle on here, and in the past I've been kind of being very good with this, but here I'm just going to quickly sketch it out. If you were to draw a unit circle there, you know the points on the unit circle are 1, 0, 0, 1, negative 1, comma 0, and then 0, negative 1. And remember, for unit circle trigonometry, which is kind of what you're going to be using when you evaluate a trig function on an axis, you're going to go ahead and use the x and y values. So again, we open an angle here, or in other words, an arc length along the unit circle. And remember that the arc of length pi over 2 is the same as the angle of pi over 2 radians for a unit circle, at least. So in this case, we just recall all of our unit circle definitions. So here we have our trig definitions as far as for the unit circle goes. Remember that we discussed last time, if you're not working with a unit circle, but instead with a circle of radius r, it would be this. So that's just the only change we would have if your circle is not unit. But we are dealing with the unit circle, so I can remove all of that. And again, all I need to know is if t is pi over 2, what do all these ratios become? So instead of inserting pi over 2 in here, because I was going to say I'm too lazy, but I'll go ahead and do it. There we go. Didn't take too much time. Now I'll just refer to this point. That is the terminal point for pi over 2. The x value is 0, the y value is 1, so the sine of pi over 2 is 1. Cosine of pi over 2 is 0. Again, x equals 0, y equals 1. But then we get to the tangent. The tangent would be 1 over 0. And we know that that number is not a number. It's actually an undefined value. So we have to say that the tangent is undefined at pi over 2. It does not have a value. And as I mentioned in a previous video, the tangent is actually, because tangent's y over x, the tangent is actually the slope of this line that's emanating out from the origin. And as our angle gets closer and closer to an angle of pi over 2, the tangent, or in other words, those slopes, end up going to infinity. They get very, very large, and so they become undefined as these slopes get steeper and steeper. Let's see, cosecant. So these are the reciprocals, right? Cosecant's 1 over y, which is 1 over 1. So the cosecant of pi over 2 is just 1. The secant, 1 over x. That'd be 1 over 0, which is undefined. And really, it's improper for me to even write equals 1 over 0 because you can't have something equal 1 over 0. But people have been doing that for a very long time, so I kind of just go along with it. But in reality, you would never say, oh, this number is equal to 1 over 0, because that number doesn't exist. It's undefined. And then the cotangent is the x value over the y value. X is 0, y is 1, so therefore the cotangent of pi over 2 is 0. That's how you evaluate a trigonometric function at an axial angle or an axis. And we can go through and do all of them. But rather than give you examples of, for example, like, oh, a negative 180 degrees or some silliness like that, let's go ahead and just practice some concepts that we've seen before. Here's an angle that is much less than negative 360 degrees. And all the trig functions at that angle are the same as all the trig functions at that angle. So I'm going to call it theta bar here, not theta hat. It's not the reference angle. I'm just adjusting this angle. So all the trig functions at negative 540 degrees are the same as the trig functions at negative 540 degrees plus 360. But if you think about that, you're still at a negative angle, and I dislike negative angles. It's just me personally. So I'll go ahead and add another 360 to that. So I'll just add 2 sets of those 360, just because I want to. You don't have to. You could have kept it at negative 540 plus a single 360, or you could have drawn it out and said, well, I rotate backwards 360 degrees plus another 180. So what is that? 360 plus 180 is 540 actually. So there you go. But the way that I've done it, as I've said, oh, well, let's consider 720 minus 540. And that is actually 180 degrees, which would be this angle right here. But they terminate, notice, at the same point. So it doesn't really matter which one of those I consider. It's basically the same thing. And remember, on the unit circle, when you terminate at that point, the point would be x equals negative 1, y equals 0. That looks terrible, so I'm going to do that again. X equals negative 1, y equals 0. There we go. And so that'll make it much easier to evaluate the trig functions. And rather than me continually writing what the trig functions are, I'm just going to assume that you already know as far as the y's and x's. So the sine of negative 540 degrees is going to be the y value, which is 0. The cosine of negative 540 degrees is going to be the x value, so that's negative 1. The tangent of negative 540 degrees is going to be the y value over the x value, which is 0. And then we have the reciprocal functions. The cosecant of negative 540 degrees is therefore going to be undefined because it's 1 over 0. So I'm just going to write here undefined. And then we have the secant of negative 540 degrees. And that is just 1 over a negative 1. So again, negative 1. And then finally, we have the cotangent of negative 540 degrees, which is the reciprocal of the tangent. That would be 1 over 0. And that is, again, undefined. So I'm just going to say it's undefined. So notice that these reciprocal functions can turn into undefined, and so can the tangent. The only two that never become undefined are the sine and the cosine, because the x and y values exist no matter where you are on the unit circle. But the other trig functions are based upon division. Y over x, x over y, 1 over y, 1 over x. And because of that, you have that danger of dividing by 0. So far we've found out that we found the trig functions evaluated at 90 degrees or pi over 2, and these are actually the trig functions evaluated at 180 degrees or pi. So we're slowly building up kind of what do all of these angles look like for each of the axes. The positive x-axis is actually fairly easy, and I didn't even create an example for that. I'll leave that for you. But let's just do one last example here before we run away from this, this video, screaming or something like that. So we rotate around 3 pi over 2 radians. That's going to land us right there. Remember, this is pi over 2 right there, and here's pi, which is 2 pi over 2. So this is 3 pi over 2. And the point there will be x equals 0, y equals -1. Now you might say, wait a second, what if I'm not on a unit circle? That's fine. If you're not on a unit circle, then sine of, let's just say 3 pi over 2 for now, normally would be y. But if you're not on a unit circle, it'd be y over r. And so if you decided, oh, I don't want my point to be on a unit circle, I want this to be 0, -5, and you talk with that voice, first of all, you're weird. But second of all, the radius of your circle would be a -5, not -5. I'm sorry, the radius of your circle would be 5 in that case. So that would mean that you'd have this radius of 5. And so when you do this, the y value is -5 over 5, or again, you'd get -1. So what's the point of working off the unit circle when the unit circle will just give you y equals -1? It's the same value. So there's no real point. All right. So that's the sine. The cosine is the x value. So 3 pi over 2 is going to be 0. And the tangent of 3 pi over 2 is going to be the y value over the x value. And that is undefined. So we can go ahead and just write undefined in there. And then you have your reciprocal functions, right? So the cosecant of 3 pi over 2 is going to be -1 over 1, which is -1. I'm sorry, it's 1 over -1, which is -1. The secant of 3 pi over 2, well, we'd get division by 0, right? Secant is 1 over x, and that'd be 1 over 0, which would be undefined. So I'll go ahead and write that in here, undefined. And finally, we have the cotangent of 3 pi over 2. Again, the cotangent is x over y, the x value being 0, the y value being -1, that will be 0. So there you have it. You have all of the trig functions evaluated at 3 of the axes. You can do the one that's just, what if you have 0 degrees or 0 radians? I leave that for you. But now, if you've watched my video series up to this point, you can evaluate all the trig functions at any axis and any special angle. Now you are completely ready to tackle the core of trigonometry.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at ease. Listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.